Hello students, today we'll be covering permutation and combination, a very important topic of higher maths. You can find many questions in CAT and XAT paper of permutation and combination. Let us see what we'll be covering in the session. First of all, we will do questions based on arrangements. Then you will see application of PNC in binomial, trinomial, multinomial. Then you will see application of probability. Then you will have practice questions along with the key. So let us start. Question number 1. It says, in how many ways can 10 persons, including A, B and C, be seated in a line such that A always comes before B and B always comes before C? See, what is a common mistake in this question? It says A always comes before B. It does not mean that A always comes immediate before B. It means just A always comes before B. So let us see. It means there are 10 places. Say 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And there are 3 persons, A, B, C and 7 more persons. But the condition is on A, B and C. What is the condition now? A always comes before B and B always comes before C. If we make cases, A can be at the first place, B can take any place from 2nd to 9th. Then we will check it for C. So there will be many cases. To avoid this, we will apply permutation and combination. How can we do that? Out of these 10 places, I'll select 3 places. That can be done in 10C 3 ways. Let us say the 3 seats are these seats. At the very first seat, we'll place A. At the second seat, we'll place B. At the third seat, we'll place C. Now our condition is okay. And the remaining 7 persons, they can be seated in any way. That's why what is the answer? It will be 10C3 into 7 factorial. What is 10C3? This is 10 factorial divided by 3 factorial, 7 factorial into 7 factorial. So we are left with 10 factorial divided by 3 factorial, and this is the answer in this case. I hope the idea is clear now. Now let us see the next question. It says, find the coefficient of x raised to power 5, y raised to power 3 into z raised to power 13 in the expansion of 2x plus 3y minus z whole raised to power 21. So let us see. First of all, instead of this question, I'll take a smaller example. Let us say x plus y whole raised to power 3. We know the formula. What is the formula? X cube plus y cube plus 3x square y plus 3x y square. Now, how can we take the expansion? If we solve it, we'll get x plus y plus xxy plus xyx plus yxx plus xyy plus yxy plus yyx. What I am doing here? I am just expanding this expression x plus y whole raised to power 3, and I am not collecting the like terms. I am not changing the order. So if we solve it, we'll get x cube plus y cube plus 3x square y plus 3y square x. Now, what is the idea actually? As you can see, we have xxy, xyx, yxx. Basically, this is nothing but x square y. Now, what is x square y? Xxy. How many arrangements are possible here? Xxy. There are 3 arrangements because y can take either first place, second place or third place. It means there are 3 arrangements of x, x, y are possible. That we are taking here 1, 2 and 3. So what is the coefficient here? It will be 3. Now let us take another thing. You can see x, y, y, yxy and yx. Again, there are 3 arrangements of yx are possible. That's why this term will come thrice in the expansion. So what is the coefficient here? This is nothing but 3. We can apply the same concept in our question. Find the coefficient of x raised to power 5, y raised to power 3 and z raised to power 13 in the expansion of this. Now, what is x raised to power 5? That is x so on up to x written 5 times. Y cube is y. What is z? Z so on up to 13 times. First of all, you will check the addition of the powers. What is this? This is 21. The total should be equal to 21 always. Then only the term will appear in the expansion, otherwise not. So, as you can see, whenever x will come, it will come with a 2. As you can see, we have 2x. Whenever x will appear, 2x will appear. Whenever y will appear, it will come in the form of 3y. Whenever z will appear, it will come in the form of minus z. So what is the coefficient here? Once again, first of all, we will take the arrangement of this thing. As you can see, there are 21 terms. 5 are alike in one way. 3 are alike in one way, y. And 13 are alike in another way. That's why that is the coefficient, but this is not the complete coefficient. Why so? Because whenever x will come, it will come with the 2. Whenever y will come, it will come with the 3. Whenever z will come, it will come with the minus sign. So what is the coefficient here? I'll take only the coefficient. So it will be 21 factorial divided by 5 factorial, 3 factorial, 13 factorial into 2 raised to power 5 into 3 raised to power 3 into minus 1 raised to power 21, and this is the complete answer. Let us move to next question. Again, there is one more question on trinomial. Find sum of all the coefficients in the expansion of 2x plus 3y minus z whole raised to power 21. If we expand this, we will get a huge expansion with many terms, and every term consists of a coefficient into some x raised to power a, some y raised to power b, some z raised to power c. But we are interested only in the coefficient. So we have to eliminate x, y and z. We are not interested in the variables. We don't need x, y and z. We need only the coefficient with the positive sign between them. That is the meaning of this question. So how to eliminate these variables? We can do one thing. We can put x is equal to 1, y is equal to 1 and z is equal to 1. If we take this, we'll be left with all the coefficient with positive sign between them, and that was the thing we need. So what is the question? 2x plus 3y minus z whole raised to power 21. We need sum of coefficients here. We can simply put x as 1, y as 1 and z as 1. So we'll get 2 plus 3 minus 1 whole raised to power 21, which comes out to be 4 raised to power 21, and this is the answer in this case. So it will be the sum of all the coefficients. Question number 4. In how many ways a student can attempt a paper containing 50 questions, each having an alternate? What is the meaning of this question? First of all, it says there are 50 questions. Say question number 1. There are 2 questions, or this. Because it says each having an alternate, it means there is internal choice. Question number 2, either or this. So in total there are 50 questions. And what is the question? In how many ways a student can attempt the paper? In how many ways can this paper be attempted? For first question, how many choices? For question number 1, there are 3 choices. How come? Either you can attempt the first question, or you can attempt the second question, or you can leave that question. That is also a choice. So for attempting every question, there are 3 choices. For first question, how many choices? 3. For second question, how many choices? 3. So on up to 50th question, how many choices? There are 3 choices. So what is the answer in this case? It will be 3 raised to power 50. Many students have confusion in this question that doing nothing, that is also an temptation. Yes, if you are taking a paper and you are doing nothing, that is also an temptation of that paper, and that is also included in this 3 raised to power 50. So this complete is the answer. Now the next question. 10 persons are sitting in a row. Find the number of ways of selecting 4 persons so that no 2 of them are consecutive. Very important question and tricky too. See what is the question. There are 10 persons. You say first, second, third, fourth, fifth, sixth, 7, 8, 9 and 10. We want to select 4 out of them such that no 2 of them are together, no 2 of them are consecutive. So if we make cases, there are numerous cases. If we count all those possibilities, obviously that is not possible because there are so many cases. So what we can do here, suppose we are choosing 4 persons and corresponding to those persons we are putting a tick. For example, if I take third person, 5th, 8th and 10th, that is a permissible way because in this case no 2 of them are consecutive. So we are putting a tick on selected persons and we are putting a cross sign on non-selected persons. So every time we are putting 4 ticks and 6 crosses, and we need that no 2 ticks are together. So it is a simple question that you have 6 crosses and 4 ticks. You want to arrange them in a line such that no 2 of them are together. Whenever you have this kind of language, no 2 of them are together, you can do one thing. The condition is on ticks. So leave those ticks. First of all, we will place crosses. There are 6 crosses and we want to adjust these 4 ticks among them. So permissible places for these ticks will be these blue arrows. In total, how many places? As you can see, there are 7 places, and out of these 7 places you want to arrange, you want to take 4 ticks, and that can be done in how many ways? 7C4. We are not going to use P, permutation here. Why so? Because already the students are arranged. We just want to put ticks among them. That's why, what is the answer? It will be 7C4. Now the next question. It says 15 students are standing on a circular track. Every student sings a song with every other student except the adjacent ones. Each song is of 1 minute. How long will this chorus be? So let us see. There is a circular track. 15 persons. They are standing on this track. Say these 15 are this way and so on. Every student is singing a song with every other student, every other possible student except the adjacent one. It means what? This student can sing a song with this student, with this student, with this student, but he cannot sing a song with the neighbors. So what is the thing actually? It becomes that this pair is possible, this pair is possible, this pair is possible, this pair is possible, again this pair is possible, this pair is possible, and so on. But these 2 lines are not acceptable. These 2 lines, they are not acceptable because any student cannot sing the song with the neighbors. So what is the thing here actually? You can see 15 points in a circular track. We can make a polygon of 15 points. Every student can sing the song with a student who is diagonally opposite to him. It means the lines are not allowed. I mean the sides of the polygons are not allowed, but the diagonals are. How many diagonals can we make? There are 15 students. We want to take pair. It can be done in 15C2, but it will give you diagonals as well as sides. So we will subtract those sides. So we'll be left with 15C2 minus 15. These many diagonals are possible for this polygon, and corresponding to every diagonal there is 1 minute. That's why what is the answer? It will be 15 into 14 divided by 2 minus 15. It will be 105 minus 15, which comes out to be 90. It means this chorus will be of 90 minutes, and this is the answer in this case. Now you can see the beauty of permutation and combination. By using permutation combination, we can solve these complex questions. Next question now. There are 4 couples. In how many ways can couple dance be arranged such that no husband dance with his wife? There are 4 couples. So there are 4 husbands and their respective wives. Say they are wife 1, wife 2, wife 3, wife 4. We want to arrange a couple dance so that no husband dance with his wife. So a possible arrangement is, say, husband 1 is dancing with wife 2, husband 2 is dancing with wife 1, husband 3 is dancing with wife 4, and husband 4 is dancing with wife 3. So this is a permissible solution. But obviously, if we start making cases, there will be numerous cases. Do we have any formula for this? Yes. First of all, this is called derangement. Whenever anything is not going to its respective place, it is called derangement. Every husband is not dancing with his respective wife. It means this is not a question of arrangement, rather this is a question of derangement. We have a direct formula for this. Derangement of n things. That can be done in how many ways? That can be done in dn ways. And what is the formula? This is n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial, so on up to, will go up to n factorial. So there are 4 things. So we want to derange 4 things. That can be done in the 4 ways. It will be 4 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. We will stop at 4, which comes out to be 24. 1 by 2 minus 1 by 6 plus 1 by 24. If you solve it, you will get 9 as the answer. So you should remember this formula, which is derangement formula. Once again, you should remember the values of derangement. What is D1? I mean derangement of one thing, that is 0. Derangement of 2 things, that is 1. Derangement of 3 things, that is 2. By formula you can verify that. Derangement of 4 things, that is 9. Derangement of 5 things, that is 44. It's better if you know these values. Now the next question. In order to get at least one head with probability greater than 0.94, I mean 94%, how many minimum number of times a coin should be tossed? First of all, what do you mean by probability? What is probability formula? That is number of favorable cases divided by number of total cases. So we are going to apply this probabilities formula. Since this is a question of coin, as you know, whenever we toss a coin, we have 2 possibilities. Either we'll get a head or we'll get a tail. So what is the probability of getting a head? That is half. What is probability of getting a tail? It will be remaining half. As you know, what is the total probability always? This is equal to 1. That's why we are taking half and remaining half. So what is the question here? That is, how many minimum number of times a coin should be tossed so that the probability of getting at least one head, that should be greater than 0.94. What do you mean by getting at least one head? It means either you are getting one head or you are getting 2 head and so on up to. Suppose we have tossed this coin n times. So what is asked here? We want to calculate what is the probability of getting at least one head. So we can make cases either 1 head or 2 heads or 3 heads and so on up to n heads. Whenever we get so many cases, we can do one thing. We can take help of reverse approach. What is the reverse approach? taking reverse of the thing asked, and we'll subtract the total from 1, because what is the total of probability always? That is 1. What is reverse of at least one head? That is probability of getting no head. It means we are getting a tail always. That is the meaning now, and according to the question it should be greater than 0.94. So my question will become this: probability of getting all tails. Now this will be equal to, since we have considered that we have tossed this coin n times and we are getting a tail always, so it will be half raised to power n, I mean half into half into half, so on up to n times. It comes out to be half raised to power n. Now we can solve it. It will be half raised to power n less than 1 minus 0.94, which is 0.06. Now you can solve it, as you must know 2 powers of 2's. As you know, what is 2 square? It will be 4, 2 cube, 8, 2 raised to power 4. This will be 16. And what is 2 raised to power 5? That will be 32. What is 1 upon 2 raised to power 4? It will be 1 by 16, and this is equal to 6.25%. It means 0.0625, but we need less than that, 0.06. So what is the answer in this case? It will be n is equal to 5. So this is the answer. It means we will toss this coin 5 times and we'll get a probability of getting at least one head as more than 0.94. Now the next question. Odds are 11:5 against an event A. What do you mean by this line first of all? Odds are 11:5 against an event A. It means probability of happening of A. This is the keyword here, against. What is the probability of happening of event A? It will be the second thing, which is 5 divided by 11 plus 5. So what is the probability of not happening of A? It will be remaining. It will be 11 divided by 11 plus 5. That is the meaning of this line. Now coming to second line. Odds are 5:3 in favor of event B. Now what is the keyword here? This, favor. It means what? Probability of happening of B. That will be what? The first thing, I mean 5 upon 5 plus 3. And what is the probability of not happening of B? It will be 3 upon 5 plus 3. So we can see that whenever you have this kind of language, that's odds are against, say, event X. Say this is equal to m:n. So what is the probability of happening of X? It will be n upon m plus n. You will take this thing here. What is probability of not happening of X? It will be what? M upon m plus n, because against word is used. Suppose the question is odds are in favor of X. Say this be P:Q. So what is the probability of happening of X? It will be P upon P plus Q. And what is the probability of not happening of X? It will be Q upon P plus Q. So you can take that. Now moving to question. It says odds are 11:5 against an event A and odds are 5:3 in favor of event B. So what is the probability of happening of A? It will be 5 by 16. What is the probability of not happening of A? It will be 11 by 16. Similarly, we can say that probability of happening of B, it will be 5 by 8. And what is the probability of not happening of B? It will be 3 by 8. Now what is the question here? Question says, what is the probability that exactly one event has happened? It means either A will happen, B not, or B will happen, A not. So we can write that required probability will be A happening but B not happening, plus B happening but A not happening. So this is the answer in this case. You can solve it. I'm leaving the calculation part for you. That's it, guys. I think I have covered all the varieties of permutation and combination. Now you can have practice questions, you can solve these questions, and you can verify your answer with the answer key. For more such concepts and videos, you can log on to hitbullseye.com. Thank you so much. Happy learning.